Tonight, we journey beyond the edge of everything you've ever known, into a place where time itself begins to lose meaning, where the sun becomes nothing more than a distant memory, a fading star, and the darkness grows so profound that it seems to swallow sound itself. But before we drift any further into this cosmic journey, if you find comfort in voyages like this one, if you've found yourself here on a night when the world feels too loud, too heavy, too fast, you can gently support this channel by liking this video, subscribing, if you haven't already, and perhaps sharing in the comments where you're listening from. Somewhere out there in the vast world, in a quiet room beneath the stars, or in that liminal space between waking and sleep where these stories seem to matter most. Thank you for being here, for choosing this moment, for letting us guide you somewhere calm and strange and beautiful. Now, let's begin. Close your eyes if you'd like, or keep them gently open. The choice is yours. But imagine for a moment that you're standing on a beach, not an ordinary beach, but one that exists in your mind, on a night so clear that every star above seems like a diamond scattered across velvet. And from this beach, we're about to take a step, a single step that will carry us outward into the solar system itself. The solar system. You know this name. You've heard it since childhood. You've seen diagrams in classrooms. Small planets arranged in neat little circles around a golden sun, as if they were beads on a string, perfectly ordered, perfectly safe, perfectly understood. But the solar system, the true solar system, the one that exists beyond those diagrams, is something far stranger, far vaster, far more mysterious than any textbook could ever capture. Imagine stepping outside on a clear night. The air is cool against your skin. There's a gentle breeze. And above you, the stars wheel slowly in their ancient dance. We think of these stars as distant, unreachably far, and they are. But what if I told you that everything above you, every single star you've ever seen, every constellation your ancestors named and mapped and told stories about, all of it exists within a neighborhood, a cosmic neighborhood, and that neighborhood has boundaries and edges, and a geography all its own. That neighborhood is your solar system, our solar system. And tonight, we're going to walk toward its furthest edge, step by slow step, moment by moment, watching as the familiar slowly becomes strange, as the sun dwindles to nothing, as silence deepens, as the universe reveals secrets that very few have ever contemplated. Let's establish something first, though, something foundational, something that will help you understand where we're going. The sun, this massive sphere of burning hydrogen and helium, this thing that has warmed every living creature that ever existed on Earth, this thing that seems so vast when you look at it through dark glasses, when you feel its heat on your face, is actually, in the context of the solar system, a tyrant, an absolute ruler, a master of gravity, and everything that exists near the sun, every planet, every asteroid, every speck of dust, everything orbits according to the sun's immense gravitational pull, this invisible force that bends space itself, that holds worlds in thrall. But as you move outward from the sun, as you travel through the regions of our solar system, something begins to change. The sun's power, while never truly diminishing, begins to weaken, slowly, imperceptibly at first, and other forces begin to emerge. Stranger forces, the gravity of distant planets, the pull of the stellar winds, the subtle pressure of light itself. All of these begin to matter more and more. And eventually, far, far away, beyond everything you've ever been taught matters, there is a place, a region, a boundary, a threshold where the sun's dominion finally ends, where the solar system itself dissolves into the void of interstellar space, where things begin to float free, to drift, to move according to laws that even scientists are still struggling to understand. This is where we're going. This is our destination. But the journey itself, that's what matters. Because to understand the edge of the solar system, you must first understand the middle. You must first travel through all the familiar places. The planets you know by name. The worlds that orbit the sun in patterns as regular as a heartbeat. Before you can truly comprehend what lies beyond. So let's take that first step, right now. Feel yourself standing on that mental beach, the one from your imagination, the one where the stars are close and the night air is cool. And we're about to turn and walk toward the horizon. Not the horizon of Earth, but the horizon of our solar system. The sun is still here, behind us. You can feel its warmth, still so immense, still so dominant, but we're beginning to move away from it. And with each step, each moment, each breath you take, we drift further and further from the light, deeper and deeper into the cosmic night. There's no rush, no urgency. Time moves differently in space. Time moves differently in stories like this. We have all night. We have forever. And the universe, patient and ancient and vast, is waiting for us to notice it, to really see it, to understand it not as a collection of facts or data points, but as a living landscape, a landscape of mystery and beauty and strange, unknowable wonders. Are you comfortable? Good. Then let us continue. Let us move deeper into the solar system, toward its hidden edges, toward the cosmic mysteries that await. As we begin this journey, we're still in familiar territory. We're still in the region of space where the sun's presence is overwhelming, where its light is bright and its gravity absolute. This is the inner solar system. And to understand what lies at the edge, we must first understand what lies here in the middle, in the realm of the planets you've known since childhood. Imagine Mercury. Imagine a small, scorched world, a world that races around the sun faster than any other planet, a world that has no atmosphere to protect it, only a barren surface of ancient craters. During the day, it's hot enough to melt lead. During the night, it's cold enough to freeze. The temperature swings are violent and absolute. Nothing could live there. Nothing could survive in such extremes. And yet, Mercury orbits the sun with a precision that's almost mathematical, a clockwork dance that never varies. Now step back, further back. Let yourself float away from Mercury. The sun grows slightly larger in your vision as you drift, and you find yourself approaching Venus. Venus is different. Venus is in many ways a living nightmare. Its atmosphere is so thick, so dense, that it creates a runaway greenhouse effect. The surface temperature is over 460 degrees Celsius, hot enough to melt lead, hot enough to cook anything instantly. And the atmospheric pressure is so extreme that it would crush you with the force of the deepest ocean trench, all compressed into the air itself. Venus is close to the sun. Venus orbits in the sun's fierce embrace. And because of this, Venus has become a world of extremes, a world where chemistry itself has run wild. Step back further still, drift outward, and now you find yourself approaching a world you know intimately, a world that has cradled your existence. Earth, our world, this small blue planet. This world with its delicate atmosphere, its liquid water, its thin layer of life that clings to its surface like a whisper. Like a prayer, Earth orbits at a distance that's just right, not too close to the sun, not too far, in a zone that scientists call the habitable zone, the Goldilocks region, where conditions are just right for life to flourish, and flourish it has, from the simplest microbes to the most complex creatures. Life is spread across every continent, every ocean, every ecosystem. And somehow, you, a conscious being, a collection of atoms that learn to think, you exist here, you're part of this world. You're reading these words that are guiding you through space. But we're still in the inner solar system. We're still in the bright regions where the sun dominates everything. There are other worlds here too. Mars, the red planet. A world that once had liquid water on its surface. A world that might have harbored life billions of years ago, before its atmosphere stripped away, before it became the dusty, cold desert it is today. And further out still, beyond Mars, beyond the orbits of these terrestrial planets, there's a boundary, a region that separates the inner solar system from the outer solar system, a region filled with countless fragments of rock and metal. This is the asteroid belt, millions of small rocky bodies, orbiting the sun in a band between Mars and Jupiter, drifting silently through the darkness. Most of them so small you couldn't see them, so distant that the sun is just another star. And yet, they orbit, they follow their paths. They move according to the sun's gravity. And in them, there's a story about worlds that never quite formed, about a planetary system that might have been, but never came to be. As we approach this boundary, as we prepare to drift into the asteroid belt, you might begin to notice something. The sun is still bright, still warm, but it's beginning to feel more distant. The light is starting to fade just slightly. You're beginning to experience twilight in space, that gradual dimming that happens at sunset, except this sunset will take hours, days, months to complete. And beyond the asteroid belt, beyond the boundary of the inner solar system, lies the outer solar system. Jupiter waits there. Saturn, Uranus, Neptune. Worlds of a different character entirely. Worlds of gas and ice and impossible storms. Worlds so distant from the sun that life as we know it couldn't possibly exist. And yet, these worlds are just as fascinating, just as worthy of our attention as the earth beneath our feet. But before we venture there, before we cross into that vast outer realm, let's pause for a moment in this inner solar system. Let's look back at where we came from. The sun is still there. Behind us, still so enormous, still so bright. But it's shrinking. It's becoming less oppressive. And as it shrinks, as its dominion weakens, we begin to realize something profound. The solar system is not a small place. The inner solar system alone, the region from the sun to the asteroid belt, spans hundreds of millions of kilometers. The distance from the sun to Earth is called an astronomical unit, or O, and it's about 150 million kilometers. That's the distance that light takes 8 minutes to traverse. 8 minutes. Think about that. The light that warms your face on a sunny day has been traveling for 8 minutes before it reaches you. It began its journey when you were in the middle of doing something mundane, something forgotten. And by the time it arrives, whatever you were doing is already in the past. And Earth is just one planet. Mercury is closer to the sun, about a third of Earth's distance. Venus is nearly as far as Earth. Mars is further, 1.5 O from the sun. And the asteroid belt extends from about 2.5 O to 4 O. 2.5 times Earth's distance. 4 times Earth's distance. All of these places, all of these worlds, exist within the inner solar system, and they're just the beginning of our journey. The universe has a way of making scale confusing. It has a way of making us feel small. But that smallness isn't a deficiency. It's not a tragedy. It's actually, in some strange way, a gift, because being small enough to wonder at the immensity around you, being conscious enough to comprehend vastness, being clever enough to build machines that can travel to distant worlds and send back images, that's a rare thing. That's a precious thing. And as we drift deeper into the solar system, as we move toward its edges, remember that every atom in your body came from a star, came from the same cosmic process that created the worlds we're about to visit. You're not separate from this universe. You're part of it, an integral part, made of star stuff, connected to everything we're about to see. Let yourself feel that connection now. Let the boundaries between you and the cosmos begin to blur, just slightly, just enough to make this journey feel more real, more intimate, more immediate. We're ready to move deeper now. The sun is still behind us, but it's no longer overwhelming. The light is softer, the gravity is weaker, and the mysteries are beginning to emerge from the darkness. As we drift further from the sun, as the asteroid belt falls behind us, we're beginning to enter a region of the solar system where things become stranger. The planets here are different. They're enormous. They're composed of gases and liquids rather than rock and metal. They orbit in a zone so distant that the sun has become, well, it's still the dominant gravitational presence. But it's no longer the overwhelming presence it was in the inner solar system. Jupiter is approaching. Jupiter is a world unlike any planet in the inner solar system. It's a gas giant. It's massive. If you were to gather every other planet in the solar system, stack them up, combine their masses, Jupiter would still be more than twice as massive as all of them combined. Jupiter is a world of storms, massive, swirling hurricanes that have raged for centuries, maybe for millennia. The Great Red Spot is a storm so enormous that Earth could fit inside it and disappear, could fit inside it and look small. And this storm has been observed for at least 350 years, maybe much longer, and still it rages. But something even stranger happens when we examine Jupiter more closely. Jupiter is not a simple sphere. Jupiter is surrounded by rings, not as prominent as Saturn's rings, but rings nonetheless, bands of dust and small particles that orbit the planet in neat, orderly circles encircling Jupiter, orbiting around this enormous world as if in some cosmic ballet. Are moons, dozens of them, dozens of small worlds, each one an individual, each one with its own characteristics, its own mysteries. And one of these moons, one that scientists have been fascinated by for decades, one called Europa, might harbor something that would change everything we know about life and the universe, and our place in it. Europa is covered in ice, a thick layer of solid ice, and beneath that ice, theoretical calculations suggest there might be liquid water, an ocean, a subsurface ocean of liquid water, kept warm by the tidal friction generated as Europa orbits Jupiter, kept warm by internal heat. And where there's water, where there's energy, the possibility of life becomes real. Isn't that strange to contemplate? Isn't there something deeply moving about the idea that beneath the ice of a distant moon, in the darkness, in the cold, life might be swimming, might be thriving, might be completely unaware of the existence of Earth, of the sun above the ice, of the stars beyond the ice. And yet it would be alive, conscious perhaps, part of the same cosmic tapestry we're woven from. But we're not staying here. We're not stopping at Jupiter. Though Jupiter is magnificent, though Jupiter deserves our attention, though Jupiter could occupy our thoughts for hours, we're moving deeper still, beyond Jupiter, further from the sun, into colder regions of space. Saturn approaches next. Saturn is the jeweled planet. Saturn is the one that even casual observers find beautiful. Saturn has rings, massive rings made of billions of chunks of ice and rock, arranged in perfect circles around the planet's equator. These rings are so vast that they would contain enough material to build a small moon. And yet they're so thin that they're barely visible when viewed edge-on. Saturn itself is another gas giant, another world of storms and weather systems. And like Jupiter, Saturn is surrounded by moons, smaller worlds in orbit around this enormous parent planet. One of Saturn's moons is Titan, and Titan is, perhaps, one of the most alien worlds in the solar system. Titan has an atmosphere, a thick atmosphere, thicker than Earth's, composed primarily of nitrogen with other hydrocarbons mixed in. This atmosphere is so dense that it obscures the surface. That makes it impossible to see what lies beneath. And what lies beneath, we now know from the Huygens lander, is a landscape of methane seas and ethane lakes, frozen at the surface, or potentially liquid beneath. A world where water ice is frozen as solid as rock, and where rivers of methane flow through valleys, and where clouds form and rain falls. But the rain is not water, it's liquid hydrocarbon. It's rain that would instantly freeze you. That would burn you with cold, that would dissolve your flesh. And yet, it's rain. It's weather. It's a process similar to the water cycle on Earth, but twisted, inverted, made strange by the alien chemistry of this distant moon. And this is where things begin to become truly mysterious, because as we move into the outer solar system, as we approach regions where the sun becomes less dominant, where the temperature drops below anything imaginable, where the pressure from the solar wind weakens, we begin to encounter worlds that challenge our understanding of what's possible, what's likely, what's conceivable. We're still in the region of known planets. We still see these worlds through telescopes from Earth. We still have detailed maps of them. We still understand their basic characteristics. But beyond Saturn, beyond the orbits of these enormous gas giants, there's a threshold, a boundary, a place where the solar system begins to transform into something else entirely. Uranus and Neptune wait there, two ice giants, two worlds so distant that they receive almost no light from the sun, two worlds so far away that sending a spacecraft to them is a journey of years, decades, a commitment to waiting that requires patience and faith and a belief in the importance of exploration, a belief that the knowledge we gain, even if it takes half a human lifetime to acquire, is worth the wait. But beyond even Uranus and Neptune, beyond the outermost of the planets we know and understand, there's something else, something stranger, something that most people on Earth have never even heard of. And that's where we're truly heading. That's what we're really journeying toward. We're heading toward the edge. We're heading toward the boundary. We're heading toward a place so strange and so vast and so mysterious that it encompasses everything the inner solar system has shown us, everything Jupiter and Saturn have revealed, and multiplies it 1,000 times over. This place has a name: the Oort cloud, or Kuiper Belt, or the regions beyond the planets. These names are still being debated by astronomers. These regions are still being mapped. These regions are still revealing secrets, still surprising us, still teaching us that the universe is far stranger and far vaster than our textbooks suggested. Can you imagine a place like that? A place so remote that the sun has become small enough to hold in the palm of your outstretched hand? A place so distant that the light that left the sun at your birth might only just now be arriving? A place so vast that it takes centuries, maybe millennia, for a single object to complete a single orbit? That's where we're going. And as we drift deeper, as the outer solar system falls away behind us, as Jupiter's enormous presence dwindles to nothing more than a bright point of light, as Saturn's rings fade into obscurity, we're beginning to transition from the known solar system to the solar system of mysteries. The sun is still there, but it's smaller now. Its light is dimmer, its gravity is weaker, and in the darkness, in the cold, in the vast emptiness, something is waiting for us. Something we've yet to encounter, something we don't yet understand. Let yourself feel the transition. Feel the gradual shift from the bright, orderly solar system of the planets to something larger, something deeper, something more profound. We're crossing a threshold now. We're moving from the region of light to the region of shadow. And in that shadow, in that darkness, the true mysteries of the solar system await. The planets are behind us now, all of them, even Neptune, the last of the traditional planets. The outermost known for most of human history lies far behind us, just another point of light in the cosmic distance. And yet, the solar system doesn't end there. The sun's dominion doesn't terminate with Neptune. There's more, always more. Always something else waiting just beyond what we thought was the boundary. And so we drift into a region that was only theorized to exist until very recently in human terms. The Kuiper Belt, a vast disk of icy bodies, a region extending from about Neptune's orbit outward, perhaps to 200 times Earth's distance from the Sun, a region so immense that the asteroid belt, that ring of rocky fragments between Mars and Jupiter, seems almost quaint in comparison. Imagine drifting into a region of space where instead of planets, instead of large dominant bodies, there are thousands, millions, perhaps billions of smaller objects. Icy bodies, dwarf planets, comets in waiting, each one orbiting the Sun according to the laws of physics, each one following its own path, each one a world unto itself, and yet connected to all the others through the invisible web of gravity. And somewhere in this region, somewhere in this vast disk of ice and rock and mystery, there's an object that for decades was considered the most distant planet in the solar system, an object so small and so distant that it took years to discover, an object that was demoted from planetary status just a few years ago, causing a controversy that spread across the world. Proof that even our understanding of our own solar system is evolving, changing, becoming more complex and nuanced. This object is Pluto, and Pluto's story is a story about how our understanding of the universe changes, how what we think we know can transform in an instant, how the universe has a way of refusing to fit into the categories we create for it. For 76 years, Pluto was considered the 9th planet. It was in all the textbooks. Children learned to memorize 9 planets, 9 orderly spheres around the Sun, 9 representatives of our cosmic neighborhood. And then, in 2006, the International Astronomical Union made a decision. Pluto was too small. Pluto was too different. Pluto didn't meet the criteria for planetary status. And so, in a decision that felt shocking to many, Pluto was reclassified, demoted, called a dwarf planet instead. But Pluto doesn't care about human classifications. Pluto continues on its ancient path. Pluto continues to orbit the Sun, taking 248 Earth years to complete a single orbit, an orbit so long that Pluto has only orbited once since its discovery, barely a fraction of one complete journey. And Pluto has mysteries of its own, strange mountains made of water ice, enormous canyons, a heart-shaped region on its surface that scientists still struggle to explain. And this is just one object in the Kuiper Belt, just one small world among countless others. There are objects with poetic names here: Iris, Makemake, Haumea. Objects with unusual compositions and strange characteristics. Objects still being discovered. Objects that will continue to surprise us as our instruments become more sophisticated, as our technology allows us to see further, to observe with greater precision. But here's where things become truly strange. Here's where the solar system begins to transform into something beyond what most people know or think about. As we drift deeper into the Kuiper Belt, as we move further from the Sun, we begin to encounter something that scientists only recently confirmed exists, and that they're still struggling to understand, something called comets. You know what comets are? You've heard about them. Halley's Comet, Hale-Bopp. These are famous comets. These are comets that have visited the inner solar system, that have been visible to the naked eye from Earth, that have inspired wonder and fear and speculation throughout human history. But where do comets come from? Where do they originate? How can something so spectacular be lurking somewhere unseen, just waiting, drifting through space? For millions of years, until gravity shifts their orbit and they fall toward the Sun? The answer lies here, in the Kuiper Belt, and in something even more distant, something we'll encounter later. These comets are ancient. They're relics of the early solar system. They're made of pristine material from the time when the solar system was forming. They're time capsules, frozen in space, waiting patiently for something to disturb them, to alter their course, to send them on a journey toward the inner solar system. Imagine a comet. Imagine a small body of ice and rock, a few kilometers across, drifting silently through the darkness. For 1,000,000 years, for 10 million years, for 100 million years, receiving only the faintest heat from the distant sun, frozen in absolute stillness. And then something happens. A nearby star passes close enough that its gravity tugs at the comet, or another comet collides with it, or the gravitational effects of a planet disturb its orbit. Something changes, and suddenly, the comet is falling toward the sun, and as it falls, as it accelerates, as it begins to be heated by the solar wind, something extraordinary happens. The ice begins to sublime. The frozen volatiles begin to evaporate. A tail forms, a magnificent tail, sometimes stretching across millions of kilometers, composed of dust and gas being blown outward by the solar wind, a tail that can be seen from Earth, that can inspire awe and wonder in anyone who sees it. And then, after weeks or months, the comet's journey through the inner solar system is over. It falls back into the outer regions, returns to the darkness, and waits again, for tens of thousands of years, for the next encounter. This is happening constantly, not every day, not every year, but throughout the solar system, throughout the Kuiper Belt. Comets are being perturbed. Comets are being pushed into new orbits. Comets are falling toward the sun and falling back again, in a cosmic cycle that has been operating since the beginning of the solar system and will continue long after Earth has been consumed by a dying sun. But we're still not at the edge. We're still not at the true boundary of the solar system. The Kuiper Belt extends outward, perhaps to 200 times Earth's distance from the sun, but beyond even that, far beyond, there's something else, something even more mysterious, something that contains objects even stranger than anything in the Kuiper Belt. This realm has almost no name yet. Astronomers are still studying it. Astronomers are still trying to understand what exists there. But the hints are beginning to emerge. The mysteries are beginning to reveal themselves. And as we drift deeper, as we leave the Kuiper Belt behind, as we move into regions that almost no spacecraft has ever reached, we're beginning to experience a transformation. The temperature is dropping. The sun is growing fainter. The darkness is growing deeper, and yet, somehow, it's growing more beautiful, more fascinating, more profound. We're approaching something vast, something that most people on Earth have never heard of, something that may redefine everything we understand about the solar system. The sun is still there, but it's just one star among thousands now, just another point of light in the cosmic darkness, just a memory of warmth, fading, but still present, still holding us, still binding us to everything that came before. We've traveled far. We've left the planets behind. We've passed through the Kuiper Belt. We've drifted beyond all the familiar territories that astronomers have mapped and studied. And now, we're approaching something that challenges the very definition of the solar system. Something so vast, so diffuse, so enigmatic, that scientists are still debating whether it truly exists as a distinct region, or whether it's simply the transitional zone between our solar system and the rest of the galaxy. This is the Oort cloud, and the Oort cloud is strange. It's not like anything we've encountered so far. It's not a disk like the Kuiper Belt. It's not composed of planets like the inner solar system. Instead, imagine a spherical shell. Imagine a halo. Imagine something that surrounds everything we've been traveling through. A vast sphere extending perhaps 1 or 2 light years from the sun. 1 light year is the distance that light travels in 1 year. Light travels at 300,000 kilometers per second. In 1 second, light travels further than the distance around Earth's equator. In a year, light travels approximately 9.5 trillion kilometers. The closest star to Earth, other than the sun, is Proxima Centauri, and it's over 4 light years away. meaning the light from that star takes over 4 years to reach us, meaning if we could see that star through our eyes, we'd be seeing it as it was 4 years ago, seeing an ancient ghost, a memory. And the Oort cloud, if it exists as theorized, extends outward to perhaps 2 light years from the sun, maybe more, maybe less. We don't know. The estimates vary widely, because we've never actually observed the Oort cloud directly. We don't have telescopes powerful enough. We don't have spacecraft capable of reaching it. We've only theorized its existence based on mathematical models, based on where comets seem to come from. Based on orbital calculations, the Oort cloud is almost entirely hypothetical, and yet it's almost certainly real. Think about that for a moment. We're journeying into a region that we're not even certain exists, not in the way where certain planets exist, not in the way we're certain about the sun's presence. We're approaching something that's almost entirely theoretical, something that exists more in mathematics than in observation, something that's a ghost, a phantom, a shadow of our understanding cast on the darkness. And in this region, in this vast sphere of ice and rock, there are objects, billions of them, perhaps trillions, objects so numerous and so distant that they've never been catalogued, never been named, never been studied. They simply exist, drifting silently through space, waiting. These objects are comets, but not the comets we know about, not Halley's Comet or Hale-Bopp. These are long-period comets. These are ancient relics that orbit the sun with periods of tens of thousands of years, hundreds of thousands of years, millions of years. Orbits so long that they might only pass through the inner solar system once every 100,000 years, which means, in the entire span of human civilization, in all of recorded history, we might only see 1, maybe 2, of these ancient visitors. And occasionally, rarely, but occasionally, something happens, the gravitational influence of a passing star, the collision of 2 comets, the subtle perturbations of mass in the galaxy. Something alters the orbit of a comet in the Oort cloud, and suddenly, a comet that has been drifting for millions of years begins to fall, begins to accelerate, begins a journey toward the inner solar system that will take thousands of years to complete. Imagine that. Imagine a comet that has been waiting in the darkness for 5 million years, receiving almost no heat from the sun, frozen solid, ancient beyond comprehension. And then suddenly, it begins to move. It accelerates, slowly at first, but always faster, falling toward the sun like a leaf falling toward the ground. A journey that will take thousands of years to complete. Thousands of years of patient motion. Thousands of years of gradually increasing speed, until finally, after a wait that spans epochs, the comet approaches the inner solar system, becomes visible to observers on Earth, shines in the night sky, and then passes beyond again and returns to the outer darkness, to wait again for another 1,000,000 years, another 5 million years, another eternity. But here's where things become even stranger. Here's where the mysteries deepen beyond what we might have imagined. As we drift deeper into the Oort cloud, as the sun becomes smaller and smaller, as the darkness becomes more and more complete, we begin to realize something profound. The Oort cloud is not an isolated region. It's not separate from the rest of the galaxy. It's connected, it's intertwined. It's part of something larger. The gravity of the sun still holds sway here, but barely. The sun's dominion extends to about 2 light years in all directions, but at that distance, the gravity is so weak, so diffuse, that other forces begin to matter. The gravity of nearby stars begins to have an influence. The tidal forces of the galaxy begin to assert themselves. The motion of the solar system through space creates currents and eddies in the gravitational field. And in these currents, in these eddies, objects shift, objects move. Objects are subtly pulled in different directions. And this is where we encounter something truly profound. something that challenges our understanding of the solar system itself, because the Oort cloud is not a static thing. It's not a frozen sphere. It's dynamic. It's changing. It's being shaped and reshaped by forces far larger than the sun, far more powerful, far more mysterious. In fact, here's something to consider. As our sun orbits the galaxy, as it completes its journey around the Milky Way's center, once every 225 million years or so, it carries the Oort cloud with it, carries these ancient objects, carries this vast sphere of ice and rock, and occasionally, as the sun's orbit brings it closer to other stars, the Oort cloud experiences gravitational stress. Comets are pulled away. Comets from other star systems might be pulled toward us. The population of comets shifts. The character of the solar system's outermost reaches changes. This is something that most people never think about. The solar system is not permanent. The Oort cloud is not eternal in its current form. The sun's dominion over these distant objects is tenuous at best, contested by the larger forces of the galaxy. And over cosmic timescales, much will change. Much has already changed, much is changing right now, even as we're speaking. But we're still not at the edge. We're still not at the boundary. The Oort cloud is vast. It might stretch for a light year or more in all directions. But even it eventually ends. Even the Oort cloud has a threshold, beyond which the solar system's gravity becomes negligible, beyond which objects are just as likely to fall toward other stars as they are to orbit the sun. And that threshold, that boundary, that edge is approaching. Imagine yourself here now. You're so far from the sun that it's ceased to be a dominant presence in your sky. The stars around you are more numerous than when you were closer, because you can see more of the galaxy from this distance. And they're all essentially equidistant. They're all billions of kilometers away. They're all other suns, other worlds, other solar systems. And somewhere ahead, somewhere deeper in the darkness, there is a place, a point, a boundary, where the solar system finally, truly, utterly ends. The temperature here is barely above absolute zero. The pressure is millions of times less than the vacuum of outer space that engineers create in laboratories. The light from the sun is so faint that you might mistake it for a star, might not even recognize it as your origin, might not even notice it among the thousands of other stars in the sky. And yet, it's still there, still exerting its gravity, still binding these distant objects, still claiming them as part of its domain, still refusing to completely let them go. Drift deeper. Let the Oort cloud fade behind you. The comets are becoming fewer and fewer. The objects are becoming more scattered. The density of matter is dropping precipitously. And ahead of you, there's something changing, something shifting, something you can feel even if you can't see it. The edge is near, the true edge of the solar system, the boundary between everything we've called ours and everything beyond. There is a moment, a precise moment, when something fundamental changes. It's not visible. You can't see it. You can't mark it on a map with a line, but it's real. It's as real as anything in the universe. And we're approaching it now. We're drifting toward it. We're about to cross it. This moment is called the heliopause, the place where the solar wind meets the interstellar wind, the place where the sun's influence becomes equal to the influence of the galaxy itself, the place where dominion changes hands, the place where we stop being part of the solar system and start being part of something else entirely. The solar wind is a constant stream of particles, mostly electrons and protons, flowing outward from the sun at hundreds of kilometers per second. The sun is always ejecting particles, always pushing them outward, always extending its influence through this stream of particles. And this stream travels outward, travels through the planets, travels through the Kuiper Belt, travels through the Oort cloud, travels outward until finally it encounters something else, the interstellar wind. the material that fills the spaces between stars, the thin gas and dust that pervades the galaxy, hydrogen mostly, helium, traces of heavier elements. This material is flowing too, not outward from any particular star, but through space, from the perspective of the sun. It seems to flow inward. It seems to press against the solar wind. And where these two winds meet, where the sun's outgoing particles encounter the galaxy's incoming particles, there is a boundary. At this boundary, something remarkable happens. The solar wind is slowed, it's compressed, it's heated. It's shaped into a teardrop-like form, with the narrow point facing the sun, and the wider portion streaming away from the sun, into space beyond. And this entire structure, this magnetosphere, this bubble of solar particles, is called the heliosphere. And we, you, me, everything we've seen on this journey, we're all inside the heliosphere. We've been inside it the entire time. The Earth is inside it. The planets are inside it. The Kuiper Belt is inside it. Most of the Oort cloud is inside it. We've been traveling through this bubble, this protective sphere, this extension of the sun's presence. And now, finally, we're reaching its edge. But this is where the definition of the solar system becomes uncertain. Does the solar system end at the heliopause? Or does it extend beyond it, encompassing the Oort cloud even though the Oort cloud exists beyond the heliopause? Scientists debate this. The definitions are fuzzy. The boundaries are blurred. Because the universe doesn't respect human categories, doesn't conform to the neat borders we try to impose on it. Imagine yourself here, at the heliopause, standing at the boundary between two winds. On one side, the solar wind, hot, active, alive with particles, originating from a specific point. The sun, with a direction and a purpose, with a will, in a sense. On the other side, the interstellar wind, cold, ancient, diffuse, originating from the background of the galaxy, with no particular direction, with no particular purpose, just existing, just flowing, just being. The temperature here is shockingly low, cold beyond anything you might imagine. Your breath would freeze before it could leave your mouth. Your eyelids would freeze shut. Any exposed skin would develop frostbite in milliseconds. And yet, this is warmer than most of space. This is warm compared to what lies ahead. This is tropical by the standards of the deep void. The pressure here is infinitesimal. If you were to breathe, you would have nothing to breathe. If you were to hear a sound, there would be no medium to carry it. If you were to speak, no one could hear you. This is the definition of vacuum. This is the closest thing to nothing that physics allows. And yet, it's not completely empty. It's not absolutely void. There are particles. 1 per cubic centimeter, perhaps just floating, just existing, just marking the presence of matter, even in the deepest darkness. And the sun that has been our constant companion, the sun that has been our reference point throughout this entire journey, it's now something else entirely. It's no longer the dominant presence. It's no longer the thing that commands attention. It's just a star, just one among billions, just a point of light in the darkness. You could close your eyes and forget about it entirely. But before we cross the heliopause, before we step beyond the boundary of the solar system, before we leave the sun's dominion forever, there's something we should acknowledge, something we should pause and consider. This sun, this ordinary star, this unremarkable point of light in the vast galaxy, has been the center of everything for our entire journey. Every world we visited, every object we've observed, every mystery we've encountered, has been defined in relationship to this sun. The planets orbit it. The asteroids are bound by its gravity. The comets fall toward it. Even the Oort cloud, even the most distant objects, are only part of the solar system because of their relationship to this star. And the sun that seemed so enormous when we began, the sun that seemed so overwhelming in its power, is actually nothing special. It's an ordinary star. Billions like it exist in the Milky Way. Billions of other stars have their own systems, their own planets, their own mysteries, their own crowds of comets and asteroids, and distant objects, all of them orbiting, all of them bound, all of them part of some larger organism, some larger system that we're about to enter. The Milky Way, the galaxy, our home, our true home. Not the solar system, not this small region of a few light years, but the enormous spiral disk containing hundreds of billions of stars, stretching across 100,000 light years. A structure so vast that the entire solar system is negligible, is invisible, is less than a speck of dust in the vastness. And we're about to see it from the outside. We're about to peer inward from the heliopause, from the edge of the sun's dominion, and see what our galaxy looks like from its outer reaches. But first, as we stand here at the boundary, let's acknowledge something else. Let's acknowledge the miracle of presence, the fact that consciousness exists, that somewhere in the universe, atoms have arranged themselves into shapes that can contemplate the universe itself, can wonder about the stars, can imagine traveling to distant places, can feel awe and curiosity and the deepest sense of connection to everything around them. That's what you are. That's what we all are. We're the universe becoming aware of itself. We're the cosmos contemplating its own existence. And from this vantage point, from the edge of the solar system, looking back at that small, unremarkable star we call the sun, we can understand something profound, something that might change how you think about everything forever. You've traveled so far. You've drifted so long. You've moved so gradually from the familiar to the strange, from the known to the mysterious, that you barely noticed the transformation. And now, as we stand at this threshold, you can look back and see the entire path you've taken. See how each step led to the next. See how the solar system revealed itself layer by layer, mystery by mystery, wonder by wonder. Are you ready? Are you ready to step beyond? Are you ready to cross the heliopause, to leave the solar system forever, to enter the galaxy itself, to see what lies in the darkness beyond the sun's protective embrace? The boundary is here. The edge is near, and nothing will ever be the same. The moment comes, not with a flash, not with a dramatic event, but gently, imperceptibly, as most profound transformations do. And you cross it, you drift across it, and suddenly, you're no longer inside, you're outside. You're no longer under the sun's dominion. You're in the interstellar void. You're in the space between stars. Behind you, the sun is still there, but it's changed. It's smaller, it's fainter. It's just another star, indistinguishable from the thousands of others scattered across the darkness. And you realize, for the first time, that this is what the sun really is. This is its true nature. Not the overwhelming presence that warmed your planet, not the tyrant of gravity that bound the planets, but a star, ordinary, unremarkable, just like billions of others. And now, standing here in this void between stars, something becomes clear, something becomes unavoidable. The solar system is over, but space continues. Space continues forever. Space continues in all directions, infinitely, eternally. And we've only just begun to understand what that means. Drift forward now. Drift deeper. The sun falls further behind. The stars around you are becoming the primary landscape. The stars are what matter now. The stars are what guide you, what define the space you're moving through, what give context and meaning to the darkness. In the space between stars, there's more than you might expect. Yes, it's mostly empty, mostly vacuum. But that emptiness is not complete. The interstellar medium, the stuff that fills the gaps between stars, contains gas clouds, dust clouds, stellar winds from distant stars, radiation from galaxies beyond, and occasional wandering objects, Rogue planets, perhaps, ejected from other solar systems, now drifting alone through the darkness. Companions to nothing, bound to nothing, simply moving, simply existing forever alone. Imagine such a world, a rogue planet, a world that orbits no star, a world that will never be warm again, that will never know the light of a sun, that will never warm the surface of oceans or light the sky above mountains. This world exists in complete isolation, and somewhere in the darkness, somewhere in the void. It's drifting, always alone, and yet it exists. It's real. It's part of the universe, and perhaps, in some way, it's beautiful, in its solitude, in its profound aloneness. There's a kind of beauty, but we're not following the rogue planets. We're not lingering in the interstellar void. We have another destination. We have another mystery to explore, because you see, as we stand here, in the space between stars, we can see something that we couldn't see from inside the solar system. We can see the Milky Way. We can see our home galaxy, not as a collection of individual stars, but as a structure, as a coherent thing, as something that has a shape, a form, a character of its own. Look around. Look in all directions. The stars are everywhere, not randomly scattered, but arranged in patterns, concentrated toward a certain direction, creating a band of light that stretches across the sky. A river of stars, a river of light. This is the galactic plane. This is the disk of the Milky Way. And we're seeing it from the outside, from the edge, from a vantage point that most of the universe never sees. The Milky Way is a spiral galaxy. It's a disk of stars, rotating slowly, taking hundreds of millions of years to complete a single rotation with two main spiral arms, and a bulge at the center, and our sun that seems so important, our sun that was the center of everything, is located in one of the outer spiral arms, about 2/3 of the way out from the center, in a region so unremarkable, so unimportant in the grander scheme, that it barely has a name. The local fluff. That's what this region is called. The local fluff. Our sun, with all its planets, with all the complexity of life on Earth, with all of human civilization, all of our history, all of our knowledge, all of our art, all of our love, and loss, and struggle, and joy. It exists in something called the local fluff. And yet, that's not sad. That's not diminishing, because being part of something larger, being part of a galaxy, being part of a cosmic structure of billions upon billions of stars, that's not a tragedy. That's a privilege. That's a gift beyond measure. Now, as we drift here in the darkness, as we hover at the edge of the solar system, we can ask ourselves, what lies beyond? What mysteries await in the deeper void? What questions might we ask if we continued to drift outward? If we continued to move beyond the boundaries of the known? If we ventured further into the darkness? The answers, the true answers, are beyond our reach. They lie in directions we haven't traveled. They lie in depths we haven't plumbed. They lie in the future, in time, in events that haven't yet occurred, and perhaps never will occur within the span of any human life. But we can imagine, we can wonder, we can dream, and in that dreaming, in that wondering, we might touch something true, something real, something that speaks to the deepest parts of ourselves, something that connects us to everything that ever was, everything that is, and everything that ever will be. The edge of the solar system is not truly an ending. It's a threshold. It's a passage. It's a doorway opening into something vast beyond measure. And as we stand here, at the boundary between the known and the unknown, we realize something that might change everything. The universe is not hostile. The universe is not empty. The universe is not devoid of meaning. The universe is mysterious. Yes, incomprehensibly vast, yes, beyond human understanding. Perhaps, but it's not hollow, it's not meaningless. It's meaningful because we're here, because consciousness exists, because the universe has arranged itself in such a way that intelligence can emerge, can wonder, can dream, can ask questions about its own existence. And that, perhaps, is the deepest mystery of all. Not what lies beyond the edge of the solar system, but why there is something rather than nothing, why the universe exists at all, why consciousness came to be, and what that means for all of us, living on our small blue world, orbiting our ordinary star, in the local fluff of the Milky Way galaxy, in a universe so vast and so ancient that human timescales seem almost meaningless in comparison. But they're not meaningless. Your time, your consciousness, your ability to wonder, that matters, that's real. That's part of the cosmic tapestry, an integral part, a necessary part, a beautiful part. And as we continue to drift, as we move deeper into the mysteries that await, carry that understanding with you. Carry that knowledge that you're not separate from the universe. You're part of it, made of it, connected to it, in ways that science is only beginning to understand. We're leaving now. We're leaving the heliopause behind. We're leaving the solar system entirely. And what awaits us? What mysteries cough on the deeper darkness? Only time will reveal. Only experience will show. Only the patient observation of an ever-expanding universe will ultimately tell, but will continue. We'll drift deeper. We'll move further into the night. And we'll trust completely in the process, in the journey, in the slow unfolding of mysteries that have been waiting, patient, eternal, for a consciousness to finally notice them. There is a quietness that comes with true understanding, a peace that comes with accepting the immensity of things. And as we drift deeper into the darkness, as the solar system has finally faded entirely behind us, as even the sun has become indistinguishable from the background of stars, something shifts in your perception. You begin to truly feel the scale of the universe, not as an abstract concept, not as a number that your brain processes and then forgets, but as a lived experience, as something you can almost touch, as something that becomes a part of you, a part of your understanding of yourself, a part of your reality. The distance from the sun to the edge of the solar system is approximately 50,000 times the distance from the Earth to the sun, 50,000 times that 8-minute journey that light takes to reach us. And yet, this distance, which is almost incomprehensible to human experience, this vast distance is nothing compared to the distances between stars. The nearest star to our sun, Proxima Centauri, is over 4 light years away. 4 light years. Which means that the light traveling from the sun to Proxima Centauri takes 4 years to arrive. And in those 4 years, the sun continues to shine, continues to change, continues to exist in time. And when the light finally arrives, when the light of our sun finally reaches Proxima Centauri, our sun is already ancient history, is already in the past, is already changed, is already different from the sun the light left. And this is 4 light-year distance. This is the distance to the nearest star, the very nearest. And yet, when you look at the galaxy, when you look at the Milky Way, the stars seem close together. They seem to form an almost continuous structure. They seem to be crowded together in a galaxy that stretches 100,000 light years across. Do you realize what that means? It means that the stars you can see, the stars that form the river of light across the sky, the stars that create the visible structure of the galaxy, they're so far apart, so incredibly far apart, that the distances between them are measured in light years, and yet they still appear close together. They still seem to be part of a coherent structure. They still form patterns and shapes and meanings in the human eye. And all of these stars, billions upon billions of them, stretching across the disk of the galaxy. All of them are suns. All of them are potential centers of their own solar systems. All of them might have planets, might have life, might have civilizations, might have beings like us, wondering about the universe, dreaming about distant places, contemplating the nature of existence. The probability is actually quite high. The universe contains so many stars, so many possible worlds, that it seems almost inevitable that life exists elsewhere, not just once, not just on a few rare worlds, but probably, commonly, frequently. Life might exist in the universe, on worlds circling distant stars, in solar systems separated from us by light years, by the vast distances that light itself takes years to traverse. And yet, we've never heard from them. We've sent out signals. We've searched the sky for signs of other intelligence. We've listened to the stars, hoping to hear a voice, hoping to make contact, but so far, the universe has been silent, impossibly, profoundly, utterly silent. What does this mean? Scientists have called it the Fermi paradox. If the universe is so vast, if life is probably so common, then why? Why do we hear nothing? Why is there no signal? Why is the universe so silent? There are countless explanations. Perhaps life is rarer than we think. Perhaps civilizations destroy themselves before they can spread across the stars. Perhaps they exist, but haven't invented radio, haven't reached a level of technology that allows communication across the void. Perhaps the universe is so vast that even light-speed communication is too slow, is too inefficient to allow any meaningful exchange. Or perhaps intelligent life does exist, is listening, is watching, is waiting for us to become advanced enough to deserve their attention, to deserve a response. But this is moving into speculation. This is moving into imagination. This is moving beyond what we can know into what we can only dream about. And that's okay. That's beautiful. Because the greatest gift of understanding the universe, understanding its true scale, understanding its vast emptiness and even vaster potential, is that it opens the door to imagination, to possibility, to wonder that transcends all boundaries. Imagine, just imagine, that somewhere out there, beyond the edge of the solar system, beyond the boundaries of the Milky Way, in a galaxy called Andromeda, or one of the thousands of other galaxies visible in the night sky, there is a world orbiting a star, a world with oceans and mountains and creatures that evolved under different suns, in different gravitational fields, under different stars, and on that world. Perhaps a consciousness is looking up, is looking at their own sky, is seeing their own sun and their own stars, and is wondering, just as you're wondering, about the nature of the universe, about the scale of it all, about what lies beyond. And perhaps in that moment, in that shared wondering, there's a connection, a link, a line stretching across the void, connecting consciousness to consciousness, wonder to wonder, dream to dream, across distances so vast that they seem infinite, and yet, in the realm of thought, in the realm of imagination, no distance can separate two minds reaching out, seeking understanding, seeking connection. This is what the universe truly is, not a collection of facts and numbers and data points, but a landscape of possibility, a canvas for imagination, a mirror in which consciousness can see itself reflected. And as we drift here, in this darkness, millions of light years from the solar system we started in, we're not alone, not really, because we're part of the universe itself. And the universe is aware of itself through us, through every conscious being that ever looked up at the stars and wondered. Let that truth settle into you. Let that understanding become part of your being. You are not separate from the universe. You are the universe experiencing itself. You are billions of years of cosmic evolution, crystallized into a form that can think, that can feel, that can love, and that can wonder at the incomprehensible beauty of existence itself. The solar system, the one we began our journey in, that was just the beginning. That was just home. The true journey, the true exploration is ongoing, is never-ending, is infinite, like the universe itself, like the possibilities that exist in the darkness, waiting patiently for someone to notice them.